Okay, let's continue with second method to find point estimation, which is known as maximum likelihood method. Okay, choose as estimates those values of the parameters that maximize the likelihood or probability. So we use L theta to denote likelihood of parameter theta. Okay, so L of theta is equal to function of x1 until xn with parameter theta. Okay, the method of maximum likelihood, or known as MLE, consists of maximizing likelihood function, which is L of theta, with respect to unknown parameter theta by differentiating natural log of likelihood function with respect to theta, then equate the derivative 0 and solve for theta. Okay, let's look at definition 1 under maximum likelihood. Okay, let x1 until xn is a random sample of size n from a discrete probability distribution or continuous PDF. Okay, this is the function. Okay, the likelihood function of the sample is L of theta. This is likelihood function of parameter theta. Yeah? This is equal to f of x1 until xn with parameter theta, and this is equivalent to f of x1 with parameter theta times f of x2 with parameter theta until f of xn with parameter theta, and this is equivalent to multiplication of fxi with parameter theta from I is from 1 until n, okay, because they are independent. Alright, so let's look at first example of maximum likelihood method. Okay, a binomial experiment consisting of n trials, okay, resulted in the observed value x1 and x2 until xn, where xi equal 1 if the ith trial was a success, and xi equals 0 if the ith trial was a failure. Okay, binomial. The outcome is either success or a failure. Okay, 1 minus p over q. Find the maximum likelihood estimator of p, where p is the probability of success. Okay, in maximum likelihood method, so the first step is to find the likelihood function of the parameter. Okay, so this is equivalent to, based on definition 1, x1, x2 until xn, based on sample lah, x1 until xn with parameter theta, and this is equivalent to multiplication of xi with parameter theta, I is from 1 until n. Okay, second step is to learn the likelihood function, and next you will differentiate ln of likelihood function with respect to parameter. If here is theta, then you differentiate with respect to theta. If here is sigma squared, so you differentiate here with respect to sigma squared, depends on parameter. Okay, and then you set this function equal to 0. Okay, so we are trying to maximize the estimator, so we set this equation equal to 0. Okay, next you solve for the parameter theta. Okay, so as you can see here, the first step is to find likelihood function, okay, for the sample. So in this case, we want to estimate p, probability of success. So based on definition, likelihood function of p lah, p is the estimator, is equal to function of x1 until xn with parameter p. So this is based on definition 1. Okay, this is equal to multiplication of function of xi with parameter p. Okay, if we expand this one, you'll get this. So as you all know, function of binomial with parameter p is equivalent to this one. So this is for only one variable x. So now we have a sample of xi, where I equal to 1 until n. So this is for xi. So you substitute lah. Replace x with xi. Next for x2, until xn. So I can simplify. I simply sum up. Okay, this x1 until xn. And as you can see here, power of x1. Okay, you total up. So equal to p power of x1 until xn. Same goes for the probability of failure, 1 minus p. Okay, and minus this. Okay, summation of xi. Next step is to apply ln to the likelihood function of parameter p. So apply ln for this term and this. Okay, so you will get this is power. So you bring this here, so we get ln p. Next, this is ln 1 minus p times the power lah, okay, which is equivalent to this one. Next, differentiate ln likelihood function of p with respect to dp. Okay, p. So here there is no p, so this is a constant. So differentiate constant, you will get 0. Next, you differentiate ln, you will get 1 over p. So this is the coefficient. Okay. Same goes for the last term. You differentiate ln. Here you will get 1 over p minus p times the constant. Alright. Next, set this term equal to 0. Okay. Set this term equal to 0. So you just substitute this one based on previous solution. Previous slide, sorry. So just rearrange. You solve for p. So what is the p hat value, right? So as you can see here, I bring this one here. So you expand 1 times x1 until xn minus p times x1 until xn. Okay, for same goes for this one, n times p equal to np, and summation of xi times p. Okay, next I think we can cancel these two. Okay, this is 0, you will get 0. So you are left with np and summation of xi ni. Okay, I from 1 until n. Yeah, actually you can simplify xi. Okay, this is sama dengan x1 tambah x2 tambah xn. Okay, next rearrange p. So for p hat is equal to summation of xi from 1 until n over n, and this is equal to x bar. Okay, so this is the moment estimator for the probability of success. Okay. Okay. Second example of maximum likelihood method. Okay, suppose that we have a sample from a Poisson distribution with mean lambda, and we know that the PDF for Poisson distribution with parameter lambda is as follows. So this is a discrete function. Okay, so we want to find the maximum likelihood estimator for the lambda. Okay, let's apply, or let's use maximum likelihood method. So the first step is to find the likelihood function. Okay, so L lambda, because the parameter now is lambda. Okay, so we know that L lambda is equal to multiplication of fxi with parameter lambda. I is from 1 until n. Okay, so general function of Poisson, exponent power of negative lambda, lambda power of x over x factorial. So you substitute. Here we have I1 and xi, I from 1 until n. Okay, so you substitute accordingly here. So I've shown here. Okay, so since we have exponent power negative lambda, so n times of lambda, so I just summarize here, exponent power of negative n lambda. And next, this is x1. This is multiplication. So x1 plus x2 plus plus xn. So I can summarize by using this term. Okay, next you combine lah, factorial x1 factorial, x2 factorial until xn factorial. So this is likelihood function of lambda. Second step is to apply ln for the likelihood function of lambda. So ln of exponent, so I do it step by step. Okay, this is multiplication, so become plus here. So power, you bring here ln of lambda. Okay, this is 1 over divide, so minus ln x1 factorial and so on. Okay, and next step is to differentiate ln likelihood function of lambda. Okay, so differentiate. This one is okay, you differentiate this, you will get negative n. Okay, this is jadi 1 over lah. Okay, summation xi over lambda. Okay, this one is negative n plus here this is constant 0. Okay, so negative n plus summation of xi over lambda plus 0. Then you equate this equal to 0. Okay, set equals to 0 so that the likelihood estimator is maximized lah. Okay, so this one is equal to 0. So then you solve for lambda, our estimator. Okay, so summation of xi over lambda equal to n. From here, you bring this over here on the right hand side, and then you solve for lambda. Okay, bawah naik atas. So this is equal to x bar. Okay.